Hi students, today I am going to explain a problem that is based on chapter 3 of your textbook. So let's first read the problem. It says, given the spatial schematic below, evaluate the flow path lengths for the following components. So it's basically, if you look at this figure here, an example is given. This figure is showing you how the layout, specific layout is designed. So we have 4 different machines, A, B, C, D. They can be machines, they can be robots, they are 4 different workstations in a particular company, right? So there is a distance is given between these 4 workstations and how they laid out. So A comes first and then B and C and D, right? So let's see that the distance between A and B is 50 feet and then another 50 feet, right? So total 100 feet is a travel distance between A and B. Similarly, between B and C is 50 feet. C and D is 75 plus 25 is 100 feet. So that's a layout. Now we have the factory makes the information given is component. The factory makes 3 different components, or you can say 3 different parts. Each part is routed differently. Each part needs different operations to be performed on the part, from the raw material to the finished product. So they have different routing requirements. So for example, part 1 is simple. It goes through its routing is A, B, C, D. That means it goes through A first, then workstation B, C and D. So it goes through the same, its routing is similar as the layout of the different workstations. So that's easy, right? So it enters into the process at A and it becomes finished product or exit the process at point D. So that's for part 1. Second, there is second component, its routing is A, B, A, C, D. So that means the part comes at A first, right? Then it goes to B. After completing the work at A, it goes to B workstation. Then some operations are performed on that part at the workstation B. Then it goes back to A, correct? Then again some operation is performed on the part at workstation A. Then from A, it goes to C, and then finally it goes to D. So there is some back and forth movement, but that's the routing for, as given here, A, B, A, C, D for part 2. Now for component 3 or part 3, the routing is A, C, B, C, D. That means first workstation that it goes through is A, then the next workstation is C. So it has to travel 50 feet, 50 feet and another 50 feet. Then it goes to C. Some work is performed on it on machine C. Then it goes, next is A, C, B. So next it goes to B, so it goes back. Then it again goes back to C and finally to D. Okay, so now we know the routing. What the question asks is, evaluate the flow path lengths for the following components. That means how much the total distance the part travels from the entry point up to the exit point. Okay, so that's probably now by now you are getting the idea, but we will do the calculations. So for flow path for the first component is A, B, C, D. So we just have to add all the distances. So between A and B, as I said before, A and B 50 50, right? 50 and 50 feet. So that's I wrote here in the bracket 50 plus 50, that is from A to B. Then from B to C, here you see another 50, so I added that 50 here. Then from C to D is 75 plus 25, 75 plus 25. Okay, so if you add all of that, so the length of the flow path or the distance traveled for component A using this routing process is total distance is 250 feet. Same calculations you can do for component 2 here, A, B, A, C, D. A, B, A, C, D, you see that distance is 50 plus 50 from A to B, 50 plus 50, right? 50 plus 50. Then from B to A, again it's going back, so again 50 to 50, so that's I put here. Then it's then when it is at A, next it goes to C, right? So then I can add that distance here. C means 50 plus 50 plus 50. That's I wrote in this bracket here. And finally from C to D, so if you go back to the figure, C to D, 75 plus 25. So if you add all of that, the second part has larger or longer length of the flow path, or it has more distance to be traveled. It's 450 feet. Then you do the similar calculations for part 3 flow path, AC, BC, D. So find out the total distance AC, then total distance CB, then BC and CD, and add all of that from this figure. You get the final answer 350 feet. So that's it. That's an easy problem here. Okay, so that's with that this completes the answer of this particular problem.